Question 2. Well, this question's not too bad once you've gathered your thoughts on this final sentence. Immediately after the collision, both particles move in the same direction and the difference in their speed is 1 meter per second. So you've really just got to gather your thoughts on this. So the first bit's fair enough. We've got the speed of P, the initial speed of P being 3 to the right, the initial speed of Q being 2 to the left. So that's why that's a -2. And we're being told, well, I'm choosing to call the speed of P after the collision, so the final speed x. Now, think about it. This is a heavier weight travelling at a faster speed. This is really going to push this one back and keep on going. So after the collision, both these particles are going to be going left to right. Now, by definition, this one's got to be going faster because he's going first. So he has to be going faster, otherwise this one would effectively overtake him, which he can't do. So that's why this v is positive x here, and how v for q is also positive, but it is the x plus 1. So we've got them travelling in the same direction, which is left to right, and a difference in their speed being 1, because q is travelling 1 faster. Then it's just a fairly straightforward conservation of momentum question. So before the collision, mass times the velocity is 3 times 3, and for q is 2 times -2, so that's our left hand side. And the momentum after the collision is m times v, so 3 times x and 2 lots of x plus 1. Now remember, that's 2 lots of x and 2 lots of 1, so that's the 2x plus 2. So gathering up and rearranging, we get x being 3/5, which is 0.6. So the speed of x is 0.6, and the speed of so the speed of p being x is 0.6, and the speed of q being x plus 1 is 1.6. Now find the magnitude of the impulse exerted on P. So the impulse is the mass times the change in velocity. So the mass of P is 3. The velocity is changed from 3 to 0.6. So it's 0.6 minus 3. That is minus 36/5. We're being asked for the magnitude of the impulse. That just means the size of the impulse. We're not worried about the direction. So the magnitude is 36/5, which is 7.2 Newton seconds.